Tomas has a question, and how about partitions on tables with column store index? That is a fantastic question, Tomas, and it is something we are going to get to in this section, but only in a few slides. So we are going to get there, and it is actually a great point about column store indexing. So where does table partitioning shine? Because I do think this is an awesome feature, and I think it has a huge amount to offer us. So one of the problems we can have is I've got this giant table and I need to load a lot of data in it, but I don't get a lot of downtime. In fact, maybe I don't get any downtime really. And I need to put this data in the table while people are querying it. Inserting lots of data or even a little bit of data sometimes into a live table, we could have blocking between us and the people who are reading the table. Now, there are other ways to work around this, like snapshot isolation. There are different things we can do, but we want to make this just easy and simple. If we partition the table, we have the ability to create a staging table separate from the partitioning table. We do need to create it on the same file group where we want the data to live in the partition. So when we create the partitioning function and then apply a partitioning scheme to it, we are going to specify, okay, here's where this partition lives, right? So each partition has a home. We need to create this staging table on the same file group as where the partition this is going to land in is. We put all our data, we insert the data into this staging table. We create indexes on it that match our partition table. The users haven't seen this at all. It's just an individual table at this point. We also create constraints on this staging table, and the constraints on it are on things like the partitioning key, so that SQL Server, these are checked constraints so that it knows exactly what range of data is in this table. And so when we switch, we can do a simple metadata operation that says, hey, take this chunk of data in this staging table and make it part of that partition table in the proper partition, which is on the same file group. And those constraints, it'll look at the constraints on the table and it'll look at the definition of the partition function. It'll be like, oh yeah, that's the right data for this partition. And it's able to do a metadata switch, and suddenly all of this data is part of the partitions table. This can be extremely powerful in some situations. It is true that to do that change and switch the data in, it does have to have an exclusive lock on the table while it does that metadata change and says, nope, this is part of the partition table now. So there can be blocking when we're doing that switch. We got some new options in 2012 where we can say, okay, wait at a certain low priority so that I don't cause a big blocking chain. So this can be huge for, I want to load a whole lot of data and just make it suddenly appear in the table. Similarly, I can have problems deleting a lot of data from a live table. Boy, can I have a lot of problems. Let's say I've got a large table and I need to delete a month's worth of data or a large amount of data. Doing this against a live table, I could use just a lot of resources, right? I'm going to have to log all those deletes. I'm going to have to figure out how to avoid blocking. It can be a real pain point. But as long as the amount of data I want to delete is an entire partition worth, with a partition table, I can say, take this partition, switch it out to an empty table on the same file group. And suddenly I do have to get that high level lock where it says, hey, I'm modifying this, all the data in this partition, it's moved. I can also move that data to another partition table, right? I can just move that data. Can be very powerful. In SQL Server 2016 and higher, I even have the ability to just truncate the data on a partition. Very, very powerful, very, very cool. You can do multiple partitions as long as you don't have any of those non-aligned indexes on the table. Very, very cool. So that is huge for managing data, right? These are not just like I'm running a query. This is I want to load lots of data. I want to delete lots of data. Similarly, maintenance. I have a table with billions of rows that is many, many gigabytes of data. The bigger an index gets, the harder maintenance gets. Rebuilding large indexes, either clustered or non-clustered, can take lots of memory grant, lots of disk access, lots of CPU. So giant indexes make longer and longer maintenance, which when people want to use our system increasingly 24/7. We're like, how am I going to do this? Well, partitioning a table can be amazing. In certain situations, partitioning a table may mean that partitions never get fragmented. If I have the type of table where it's a fact table, for example, and I have new data coming in and I'm partitioning on a date range, these partitions by date, my older dates, that data is never changing. I just have new data coming in from my fact table. So suddenly, I now have a situation where maybe I don't even have to rebuild these indexes because they're not getting fragmented because they're all on a range of dates and the data just isn't changing. In some situations, maybe I have an active partition and I only need to rebuild data in that partition. This can absolutely be fantastic and can simplify my life. Even if I have data changing in a lot of partitions, we have online partition level rebuilds in recent versions of SQL Server. We haven't had this forever, but I can at least now break up the operation into a smaller chunk that isn't rebuild this huge giant thing at once, but I can iterate through the partitions and just deal with them on a smaller level, doing smaller units of work that are less disruptive to our customers, potentially to our availability group secondaries, right? We're putting smaller amounts of index rebuild modifications into our transaction log at once. It can be very, very powerful for maintenance and for managing these large chunks of data. This also applies to corruption checking, but I have to be a little bit clever. Checking, let's see, I can do, check table in SQL Server. Let's say I have a huge database, many terabytes of data, and CheckDB just takes forever. I can write my own custom scripts to do check table, and then there's a few other things CheckDB does besides check table. So I can do a custom script to do that. But in some databases, even running check table is like just too much work to do at once because even if it's partitioned, this partition table may be huge. We do not have the ability to check an individual partition. Some folks have asked for this, but it's never happened. And this is one of those things where I'm always like, we do constantly get improvements in SQL Server. I'm always like, oh, did we get that? Okay, I don't think we've gotten that yet. Because we do have a workaround. Even though we don't have check partition, we do have check file group. So I have the option when I create a partition table. I can use one file group for all of my partitions if I want. I can use one file group per partition, or I could put I get to specify where do I want to put each and every partition. I could say put them all in one place, or I could do whatever I want. So sometimes, I'm not saying that I don't always recommend one file group per partition because sometimes just managing all those file groups is a big old pain. But, however I want to lay it out, I often, with giant tables, I don't want to use one big file group for them, even if I have a fancy SAN that does storage tiering, because I may want to use DBCC check file group. So breaking them up into certain digestible sized chunks for CheckDB can give me the ability to not have to check the whole table at once. I can break up my corruption checking so that in my ever-shrinking maintenance window, I am able to check for corruption, and that can be really useful. Table partitioning in these giant databases can also help with our backups, right? If I have a database that's, 3 terabytes, 4 terabytes, 5 terabytes, we're up to 10 terabytes, backing up all that data can take longer and longer and longer depending on what technologies we're using, how we want to store our backup, how many copies of our backup we want to use, and all of that. Making these individual backups can be huge. If we are able to, we're not depending on the pattern of our tables, if we do have a partition table where we're partitioning on a key and large amounts of the table isn't changing, we have the ability, if we're spreading this out on different file groups, to make some of those file groups read-only. Then we can move to file group level backup. And for those read-only file groups, we know data isn't changing there. They're read-only, so we can guarantee it. So I can back up those read-only file groups and have to be careful to keep my backup. I have to make sure, I'm going to want to test it. I'm going to want to make sure it doesn't fall prey to disk corruption. I'm going to need to take some care, right? Because even a good backup could have the disk corrupt under it. But I don't have to back up those read-only file groups constantly, and I can make backups much shorter with that too. So managing data and living with these databases and getting away from the problems can be made much easier with partitioning. It can be very, very cool to make your life better. And getting back to column store, we have cool new indexes in SQL Server. So far, I've been talking about row store indexes in SQL Server, those B-tree indexes. What if we're using new columnar technology? And this can be fantastic, especially for queries that do aggregates that want to scan lots of data. Well, one of the things about column store is column store just doesn't support seeks. It's columnar data and it's not organized in a nice little B-tree where we do a seek. It's very, very different. Column store does have something called row group elimination, where it can look at metadata on an individual row group and figure out for certain data types, not all data types, but for certain data types, figure out, hey, does this row group contain anything relevant to my query? And it's able to skip it. But still, if we have a really large column store index, that row group elimination, it can speed me up, but it's not the same as being able to do a seek. So if I partition my column store index, and with column store, even just having a column store, you need to have minimum amount of data, right? Your column store isn't going to perform very well if you just have a few little rows. We're talking about big tables here. But if I partition my column store index, I can get partition elimination on my partitioning key. Now, that's not the same as a seek, but it is pretty powerful because SQL Server can actually combine partition elimination with row group elimination. It can figure out, oh, I don't even need to look at those other row groups to see if they're pertinent to me because the partition elimination tells me all the data I want is over here. And then within that partition, I can, if it has multiple row groups, I can do row group elimination on those. It is awesome. Also, I have the ability to super compress some data in my column store index if I want, but there is a trade-off for query performance. And if I have partitioned my clustered column store index, I can now say, okay, on these older partitions that I just don't use very often, I want to super compress those to save space. And, because it's fine when I query those, it's fine if it's a little slower. We don't do it very often. Very cool option to have. Now, you may be looking at the slide and be like, wait a second here. You said table partitioning doesn't speed up query performance, but actually in this case of column store indexes, this does sound like getting partition elimination could speed up query performance here because in this case, I don't have the option to do a seek otherwise. And row group elimination, I've made my I've sort of supercharged my row group elimination by adding partition elimination on top of it. And yes, I do admit, in this one case, I'm like, yeah, okay, this does speed up queries, right? Generally, table partitioning is not something I would look at to be like, oh, my queries are slow, I need to speed up my queries. But in this case, with big column store indexes, yes, this can speed up your queries. Honestly, there are other reasons you would want to do it for these giant column store indexes as well. Just in terms of managing the column store indexes and being able to use switching often really makes sense. I often do not want to do live inserts into my column store index, even though I can in many versions of SQL Server. It's much nicer if I can load up data for my partition column store index and then switch it in that case too. But yes, I do think in this case, there is a case to be made that in this situation, table partitioning does speed up query performance. So there's an exception to many rules. And I think that this is the exception in this case. I don't know if it proves the rule, but I think it is kind of an exception. Now, with complexity comes gotchas. The more complex we make our SQL servers, the more we use these cool features, the more likely we are to hit a little edge case where something that should be fast, we hit an issue and it isn't fast anymore. And that's just because, the faster we're driving in the race car and the fancier we make the race cars, the harder it gets to do things. So, and there is an example in this case where before 2016, some partitions were being scanned that shouldn't be scanned in a partitioned column store index. Nico, if you're into column store and you haven't been reading Nico's blog, Nico Port is his blog, you should check it out. I have a short link here. This is part 103 of his column store posts. So he has fantastic posts on column store, including talking about things like partitioning. And this is just an example of one of those things where he found, oh, hey, this thing is slower in 2014 than it should be. It's fixed in 2016, but it's just an example of you may come across these, the more complex we make things, we may come across these little things where like, this isn't quite as good as it could be. And hopefully those get fixed for us. Sometimes we have to do a workaround ourselves and rewrite our code.